All right, so now we're going to be talking about average rate of change of a quadratic, specifically intervals on the quadratic. So this really isn't going to be too terribly difficult. We're not using any new information other than we're using quadratics instead of linear equations, but the process is the same. So I can define the interval that has a specific rate of change, calculate the average rate of change over a specific interval when given a table, determine the interval in which the rate of change is the greatest, and explain the difference between rate of change over a specific interval versus over an entire quadratic function, as well as sketch the graph of that function. So, because this is nothing new, remember average rate of change, formula for rate of change is y2 minus y1 over x2 minus x1. We're going to be using that frequently. So, between which two coordinates is the average rate of change -1? So the key here, so rather than try and find a whole bunch of different rates of change, we have a negative sign, which tells us that we're looking for something on this side, because this is where our rate of change is decreasing. Over here it would be increasing. So we're looking for a decreasing rate of change. And we're looking for a rate of change of -1. So that means something that goes down 1 and right 1. So basically something that will, if we drew a straight line between the points, would give us this. Now, you can eyeball it to help you. Like if I look at this, obviously that's steeper. So is this. This is looking good because we go down 1, right 1, which is a slope of -1. So that's all you're doing, is looking for the interval in which it does that. So it's between 0, -3, which is right here, and 1, -4, which is right there. Second example, determine the average rate of change between, so y is between 1981 and 1999. So greater than or equal to 1981, less than or equal to 1999. So even though this would be like a quadratic function, or would have a curve to it, all we have to do for rate of change is take those two dates and find the price there. And remember, so that's going to be your x and y. Actually, so the price depends on the year. So even though year here says y, it's actually your x value. Don't get that confused. Okay. First column, almost always your x value. Second column, almost always your y value. So we have our 2 points, and all we have to do is apply that rate of change formula. So we have 33 minus 18, so this minus this, and then since we start with 33, we have to do 1999 minus 1981, which gives us positive 15 over 18, which comes out to a decimal of 0.83333. Basically, 3 is repeating, so we can just write it like that. It would be better, because whenever we're finding the rate of change, we have a word problem, we want to keep it in this form. We don't want to leave it as a fraction. Okay, next example. Between which two coordinates is the average rate of change the greatest? So we're looking for where the average rate of change is. So, and it says the greatest. So, difference between where is the greatest rate of change and where is the rate of change the greatest. Greatest means the highest. So we're looking for the biggest number, unlike past problems where we're just looking for the biggest change. So this is the biggest number. So that can rule out anything over here, because all these rates of change are going to be negative. So now we're looking for positive. So what you can do again, you can kind of like cheat a little bit, draw your lines. Now that's not exactly the straightest line. And see which one is the steepest or the closest to vertical. That's going to give you your greatest rate of change. You can also plug in a bunch of points and you can find the rate of change for each one. What you would do is just say, if you wanted to do it algebraically, like we could look at our points, 1, -4, and 2, -3. Okay, find the slope for that, which is 1. Then we would look at 2, -3, and 3, 0. Find the slope for that, which is 3. Like I said, you can kind of tell from looking at it that this is the greatest, but it's always good to have the numerical proof. So then 3, 0, and 4, 5, go ahead and find the slope for that, which is 5. So the greatest, because 5 is obviously the biggest number there, is between 3, 0, and 4, 5. Now, it didn't say to show your work. It didn't say how to do it. So how you do it is up to you. But here's how you do it numerically. And then this is kind of like how you eyeball it, like which one is the closest to being straight up. Fourth example, so we're given this function, forget about this for a second here, we're given this function, determine the average rate of change from x equals -1 to x equals 0. So what you can do is you can go through and you can do this and plug in -1 for your x to get your y. So this would be y equals 2. So that would be when x is -1, y equals 2. Then you can also take, should have disappeared, but that's good that I wrote it down then, and plug in 0. 0 squared plus is 0. 4 times 0 is 0, which leaves you with just 5. So 0, 5 is your other point. Okay, then you can go ahead and you can take your slope. 5 minus 2, 0 minus -1 gives you a slope of +3. Okay, so we have a slope of +3. If we draw in our graph, it says draw a line segment connecting the corresponding points at x equals -1, so that's right there, and x equals 0, which is right there. So B, we drew it in. Then we're going to go ahead and we're going to just remember it's rise over 1, so we're going up 3. Why isn't this writing? Up 3. Let's see if we can get it to work. Okay, apparently it doesn't want to work. Anyway, we go up 3 and right 1. Rise over run. So with 3, it's the same, so that's good. Does it represent the average rate of change? Now notice it's asking whether it does for the entire function. Okay, the entire function. Which obviously it does not, because it would be different everywhere else. So we say the average rate of change will be different for every different interval. For example, the average rate of change from x equals -2 to x equals -1 is simply just 1. So you get the idea there. Last example. Function below models the path of a projectile over time. We want to determine the average rate of change of the function between 0 and 1. We want to determine the average rate of change of the function between 1 and 2 and interpret the meaning of the varying rates of change. So we've got, I would suggest labeling those 3 points when x is 0, x is 1, and x is 2. It'll make it easier. So you can do it algebraically. Okay, 5 minus 0 over 1 minus 0 is 5. That answers A. For B, same thing, except we're going to be doing, went backwards. 0 minus 5 over 2 minus 1, which is -5. The meaning of the varying rates of change, well, from 0 to 1, the height of the shot put is increasing until it reaches its peak height, and then from x equals 1 to x equals 2, it decreases in height. We're not always going to have it so that the rate of change is equal. You might be describing 2 different points. You could be describing, for example, the rate of change from 0 to 0.6. Versus 1 to 1.2. So this would be obviously be a steeper rate of change, because this would be as it's just beginning to fall, and you would describe that as well. So just be a little more specific in it. But again, this is nothing new, no new formulas or anything to remember. It's just a matter of switching up your interpretation of things just a little bit. But as always, if you have any questions, please do not hesitate to let me know. Take care, guys.